Good evening, children. So, today we'll start a new chapter, that is air, which means wind. So, what we shall learn in this chapter is about the composition of the atmosphere, atmospheric layers, insulation, and measurements of degree of heat, weather and climate, and the differences, instruments that are being used in determining and forecasting weather, factors that affects the atmospheric pressure and temperature, and lastly cyclones and jet streams. So to start with, let's first learn about atmosphere. Now, what is an atmosphere? You all have learned this even in class 5 and 4, that atmosphere is a layer of air that surrounds the entire earth, or you can say it's a blanket of air that covers or surrounds the earth. Now, we may not see the air, but we can feel the air, and very much like water, the air has no definite shape or color, but it has weight, and that's why it exerts pressure, and our body is constantly under the pressure of this air. Now, it's about 7 kilogram on every square centimeter of our body. Like on our every square centimeter of a body, there is a pressure of 7 kilogram of air, but we do not feel this pressure, right? Do we? No. If we could feel the pressure, then just imagine 2 or 3 or even 4 5 sacks of potato or onion bags, a sack of rice, 2 3 bags on your head. Will you be able to walk? No, you won't be able to walk. There will be a lot of pressure. So likewise, that much of amount of weight is being there on top of our head, but we do not feel that. Why? Because our body, our lungs, our organs from air, they also exerts pressure, and so the balance inside and outside is maintained. And we can just feel the air when the wind blows, or if you are in the room and if the fan, your ceiling fan or any other fan is moving, then only you can feel the air. Now, this air is not same at every level. The more you are near the sea level, the more the air is dense. As you go high and high, the air becomes less denser, or less dense, sorry. What is this air? It's not a single component. It's a mixture of various gases. Now, what does this air or this atmosphere comprise of? Now, the air that surrounds us is a mixture of number of gases such as oxygen, nitrogen, carbon dioxide, helium, and others, along with dust particles and smoke, out of which oxygen is very important for living things on the earth. We survive on this earth just because of we inhale this gas from the air, that is oxygen. There's about 21% in the entire atmosphere, and this oxygen helps not only in help us in breathing, but also it helps in burning. The next gas that is in much larger amount is nitrogen. It constitutes about 78% of the entire atmosphere, and this is a very inactive gas. But though it is inactive gas, but yet it is very important because it acts like a brake. If the nitrogen gas would have not been there in the atmosphere, then today things would have been completely different. In fact, there would have been no living organism on this earth, because the moment you light a matchstick or you burn anything, boom, the entire thing would have been burned into ashes because of the oxygen. But since there is nitrogen, it acts as a brake. It slows down the burning process. We also need nitrogen compound for our body growth, but we cannot directly inhale nitrogen from the air. So this nitrogen, during when rain pours down, it gets mixed with the water and then adds with the soil, and from soil the plants take in the nitrogen compound, and then we eat those plants, and that's how we get nitrogen compound. Then the other gases present in the atmosphere are argon, helium, ozone, carbon dioxide also. So 78% nitrogen, 21% oxygen, and the remaining comprise of the other gases, water vapors and dust particles along with smoke. But the amount of water vapor and dust particle in the atmosphere is not same in each and every places. It depends, or it varies from place to place. Place where it rains in the atmosphere in that particular area will have more water vapor than the places where there are a lot of factories and industries and cars and other vehicles run. In that places there will be a lot of smokes and dust. So these things like dust, water vapor and smoke is not same in the entire atmosphere. They vary from place to place. Now the structure of the atmosphere. Now the atmosphere has a layer of varying densities. Now the air at the lowest layer is the heaviest because of the pressure of the upper layers, and the upper layers are less denser or thin. Now about 90% of the mass of the air lies within the height of about 20 kilometers from the surface of the earth. So from the surface of the earth up to the height of 20 kilometers, within this area 90% of the entire air mass is present, and the remaining 10% is beyond that 20 kilometer high up above in the atmosphere. Now the different layers of the atmosphere are troposphere, stratosphere, ionosphere and exosphere. Now these are the main layers that we'll discuss, because when you go to higher classes you'll get to learn more about other sub-layers that lies between the troposphere and stratosphere. Then there is also a sub-layer between stratosphere and ionosphere, then exosphere and ionosphere. So that when you go to higher classes you'll get to learn more about that, but here we'll just discuss about the main layer. Now the closest layer to the surface of the earth, or the bottom most layer, is the troposphere, and its height from the earth's surface varies from about 8 kilometers at the poles to about 18 kilometers near the equator. Now the temperature within this layer keeps on dropping at the rate of 1 degree Celsius for every 166 meter of ascent. That is, in this layer, as you go high and high, the temperature decreases, and that is 1 degree Celsius for every 166 meter. That is, when you climb 166 meter, the temperature will drop down 1 degree Celsius. For example, suppose you are at a height of say 20 meter, then from 20 meter you climb up 166 meter. The temperature is say 18 degrees Celsius. As soon as you climb 166 meter, the temperature will drop down to from 18 to 17. Again from that you climb up 166 meter. Again from 17 to 16. So as you go up, for every 166 meter, the temperature drops down. That is 1 degree Celsius drops down. This layer, troposphere, is the most turbulent layer because it contains plenty of water vapor, the clouds, the thunder, the rain, whatever. Everything happens in this particular layer, the troposphere. Now above the troposphere lies the stratosphere, and it extends up to a height of 62 km at the equator and 72 km at the poles. And there are hardly any clouds or dust in this layer. In the stratosphere, you will not find much of clouds or dust or water vapor. And the temperature is almost constant. And this zone is very rich in ozone. You know ozone? So ozone is a gas that protects us from the harmful radiation of the sun, that is UV rays. And almost all the aeroplanes, they fly in this layer, stratosphere. Then the next layer is the ionosphere. It is about 970 km above the stratosphere, the extent of this layer. And this zone is named because it contains electrically charged particles called ions. And all the radioactive, wireless signals that is being sent back to the earth is from this layer. This wireless communication becomes possible through the help of this layer because it contains ion. All the telephone signals or TV signals are being reflected or sent back to the earth from this layer, ionosphere. And when a spacecraft that goes into the space, when they come back, they burn. That's why every spacecraft, they have a heat shield to protect themselves from burning. And it's in this layer, ionosphere, where the spacecraft completely loses out its contact with the earth for about 2 or 3 minutes. Even the very tragic accident that took place, I forgot the year, in which the Kalpana Chawla died. The space shuttle Columbia exploded. It's in this layer, ionosphere. Then the topmost layer is the exosphere. It is the uppermost layer of the earth, and not very much is known about the structure, but you won't find much air in this part of the exosphere. Even if you find, you'll find hydrogen and helium much in this part of the atmosphere, and it extends up to a height of 1600 km, and beyond that is what we call space. So this is about the atmosphere and its structure. So what we have learned here is about what is atmosphere, what is atmospheric pressure, why we do not feel the air pressure. Then we also discuss about the composition of the atmosphere, the various type of gases, the usefulness of nitrogen and oxygen. Then we also discuss about troposphere, stratosphere, ionosphere and exosphere. The next that we shall discuss in the next class is about insolation, measuring and degree of heat, weather and climate, factors affecting temperature. Now what I would like to tell you is that we'll go together. So page number 30, question number 1, 2, 3, 4. Homework for you. Question number 1, 2, 3, 4. Like, why do we not feel the pressure of air on our body? The answer is simple, as I have told you. We do not feel the pressure of air on our body because our body also exerts air, and the balance inside and outside is maintained. That is the answer for question number 1. Then question number 2, what is the function of nitrogen? So the function of nitrogen is, it prevents what? What does it prevent? I think I have told you. So it acts as a brake and prevents the burning process, or it slows down the burning process. So the function of nitrogen is, it slows down the burning process. The next, number 3, is name the different layers of the atmosphere, that you can see in the book and write. And why is ionosphere so named? That is also we have discussed, because it has electrically charged particles called ions. That's why its name is ionosphere. That's all for today. Thank you.